Good afternoon all. This is Satish Kumar, Assistant Professor of EC Department. Now let us discuss about the Chebyshev filter in IIR filter design. Designing of low-pass digital Chebyshev filter means for designing a Chebyshev IIR digital filter, analog filter is designed using the given specifications. The analog filter transfer function is transformed into digital filter transfer function by using either impulse invariant or bilinear transformation. The analog Chebyshev filter is designed by approximating the ideal frequency response using an error function. The approximation function is selected such that the error is minimized over a band of frequencies. There are two types of Chebyshev approximation, type 1 Chebyshev approximation and type 2 Chebyshev approximation. In type 1 approximation, the error function is selected such that the magnitude response is equiripple in the passband and monotonic in the stopband. In type 2 approximation, the error function is selected such that the magnitude response is monotonic in the passband and equiripple in the stopband. The type 2 magnitude response is also called as inverse Chebyshev response. The magnitude response of type 1 low pass filter is given by h of j of omega the whole square 1 divided by 1 plus epsilon square into cn square ohm divided by ohm p. E is nothing but epsilon attenuation constant, therefore which is equal to Cn into ohm divided by ohm p represents your Chebyshev polynomial of order n. Next one, attenuation constant is given by epsilon is equal to 1 divided by ap square minus 1 the whole power 1 by 2. A is nothing but gain or magnitude in the passband H frequency at ohm p. For small values of n, how to determine the Chebyshev polynomial? C n of x is equal to cos into n into cos inverse of x. For more magnitude of x should be less than or equal to 1. Cos h of n into cos h inverse of x for magnitude of x should be greater than 1. This is the condition for your small values for how to determine your Chebyshev polynomial. Next one, properties of Chebyshev filter. The magnitude oscillates between 1 and 1 root of 1 divided by 1 plus epsilon square within the passband, so that the filter is called as equiripple in the passband. The normalized magnitude response has a value of 1 divided by root of 1 plus epsilon square at cutoff frequency ohm c. The magnitude is monotonic outside the passband. The Chebyshev type 1 filters are all pole designs. For large values of n, the transition from the passband to stopband becomes more sharp and approaches the ideal characteristics. This is the overall magnitude response of the analog Chebyshev type 1 low pass filter with respect to h of j ohm with respect to ohm. We can how to find out your ideal frequency response means with respect to 1 divided by root of 1 plus epsilon square. For determining n is equal to 1, n is equal to 2, 4 and 8. The overlapping will be for both Chebyshev type 1 filter and Chebyshev type 2 filter can be given is represented as follows. Is equiripple in the passband and monotonic in the stopband. For n is the order n is equal to 2, n is equal to 4 and n is equal to 5. Next one, we can see the magnitude response of analog Chebyshev type 1 filter. The analog Chebyshev type 1 filter is the error function is selected such that the magnitude is equiripple in the passband and monotonic in the stopband. See, equiripple with respect to AP is nothing but passband gain. 1 divided by root of 1 plus epsilon square, that is passband is nothing but equiripple, stopband means monotonic. For n is equal to even, the graph may be varied. AP is equal to 1 divided by root of 1 plus epsilon square with respect to passband and monotonic in the stopband. In magnitude response of analog Chebyshev type 2 filter, the error function is selected such that the magnitude is monotonic in the passband and equiripple in the stopband. See, passband H frequency is monotonic and equiripple in the stopband with respect to gain is nothing but 1 divided by root of 1 plus epsilon square. Similarly, for n is equal to even is monotonic in the passband and equiripple in the stopband. With respect to gain is nothing but AP passband gain is nothing but 1 divided by root of 1 plus epsilon square. Next one, how to find the cutoff frequency. The IIR filter is designed to satisfy the gain at the passband and stopband edge frequency, but practically cutoff frequency is used to decide the frequency range of the filter. In Chebyshev filter design, the passband and stopband specifications are used to estimate the order n of the filter. The passband edge frequency ohm p is considered as cutoff frequency ohm c, and the cutoff frequency is not equal to 3 dB cutoff frequency. Ohm of dB is equal to ohm c into cos h of 1 divided by n into cos h inverse of 1 divided by epsilon. Next one, design procedure of low pass digital Chebyshev IIR filter. Omega p is nothing but passband edge digital frequency in radians per sample. Omega s is equal to stop band digital frequency in radians per sample. AP gain at passband edge frequency omega p. AS gain at stop band edge frequency omega s. T is equal to 1 by Fs. T is equal to sampling time. Fs is equal to sampling frequency. Ohm p is equal to passband edge analog frequency corresponding to omega p. Ohm s is equal to stop band edge analog frequency corresponding to omega s. Next one, how to find out the design procedure for a given Chebyshev IIR filter design. First, we can choose the given summers, either bilinear or impulse invariant transformation, and determine the specifications of equivalent analog filter. The gain or attenuation of analog filter is same as digital filter. In case bilinear transformation means ohm p is equal to 2 by t into tan of omega p by 2. Ohm s is equal to 2 by t into tan of omega s by 2. For impulse invariant transformation, ohm p is equal to omega p by t. Ohm s is equal to omega s by t. Next one, we can decide the order n of the filter. How to find out the order n of the filter? N1 is equal to cos h inverse of 1 divided by a square minus 1 divided by 1 divided by 1 by ap square minus 1 the whole divided by 1 by 2 divided by cos h inverse of ohm s divided by ohm p. Next one, normalized transfer function for analog filter. When n is even means h of s of n is equal to summation k is equal to 1 to n by 2 b of k divided by sn square plus bk into sn plus ck. Where n is odd means h of s of n is equal to b naught divided by s plus c naught. Pi k is equal to 1 to n minus 1 by 2 bk divided by sn square plus bk into sn plus ck. For how to find out the bk, 2 into y of n into sine of 2k minus 1 into pi divided by 2n. How to find ck? Y of n square plus cos square into 2k minus 1 into pi divided by 2n. C naught is equal to y of n. How to find the epsilon? 1 divided by ap square minus 1 the whole power 1 by 2. How to calculate y of n? 1 by 2 into 1 by epsilon square plus 1 the whole power 1 by 2 plus 1 by epsilon the whole power 1 by n minus of 1 by epsilon square plus 1 the whole power 1 by 2 plus 1 by epsilon the whole power 1 by n. Next, n be the order of the filter. For even values, how to calculate b of k means when s of n is equal to 0, 1 divided by 1 plus epsilon square the whole power 1 by 2. For all values of n, the parameter b of k can be evaluated. H of s of n is equal to Sn of n is equal to 0, which is equal to 1. By evaluating b of k, to take b naught is equal to b1 is equal to b2 is equal to up to b of k. Find for your normalized transfer function, normalized transfer function is obtained by replacing Sn by S by ohm c in the normalized transfer function. How to find means h of s is for a given equation, you can replace your Sn is equal to S by ohm c. Therefore, h of n is even, h of s is equal to pi k is equal to 1 to n by 2 bk into ohm c square divided by S square plus bk into ohm c into S plus ck into ohm c square. Where n is odd means for normalized transfer function even formula, to replace Sn which is equal to S by ohm c. Therefore, h of s is equal to b naught into ohm c divided by S plus c naught into ohm c. Pi k is equal to 1 to n minus 1 by 2 bk into ohm c square divided by S square plus bk into ohm c into S plus ck into ohm c square. Next one, Determine the transfer function of the digital filter h of z by using which transformation to transform h of s to h of z. When impulse invariant is employed means then multiply h of z by t to normalize the magnitude. Realize the digital filter transfer function h of z by a suitable structure. Verify the design by sketching the frequency response h of e power j omega. H of e power j omega is equal to h of z, where z is equal to e power j omega. Next one, what is Chebyshev approximation? The Chebyshev approximation is selected to determine the frequency response of a transfer function, approximation function. The approximation function is selected such that the error function is minimized over a band of frequencies. How will you choose the order n for a Chebyshev filter? N is equal to cos h inverse of 1 divided by a square minus 1 the whole divided by 1 divided by ap square minus 1 the whole power 1 by 2 divided by cos h inverse of ohm s divided by ohm p. List the types of Chebyshev filter. Type 1 Chebyshev approximation, type 2 Chebyshev approximation. List the properties of Chebyshev filter. The type 1 Chebyshev filters are all pole design. The error function is selected in type 1. The error function is selected such that the magnitude response is monotonic in the passband and equiripple in the stopband. The type 2 magnitude response is also called as inverse Chebyshev response. Analog filter transfer function is converted to digital filter transfer function by using either impulse invariant transformation or bilinear transformation. Attenuation constant is given by epsilon is equal to 1 divided by ap square minus 1 the whole power 1 by 2. Thank you.